All right, here they give us a curve, gives me some parametric equations, x of t and y of t, tells me its position. So that's the x position, that's the y position. First thing they ask is for dy dx in terms of t. Then they ask for the equation of a tangent line. And then they ask to give the curve in terms of just x and y as opposed to x, y, and t. So let's start with A. All right, so you should know that dy, hold on a second, over dx, the way that we're going to calculate that is we're going to do dy over dt divided by dx over dt, because the dt is canceling, give me dy over dx. So dy over dt is the same as y prime of t, which this one, you should see that y it's the same as t plus 1 to the negative 1. So I got to do power rule, little bit of chain. That gives me negative 1 over t plus 1. The power rule makes it a 2 in the bottom. You may say, wait, where'd this negative 1 come from? Well, it came from doing power rule with this and multiplying by negative 1 out front. Then I'll go ahead and do dx dt in blue. Dx over dt is equal to, again, it's a little bit of chain rule. Actually, what I'm going to do is rewrite x using negative powers, negative fractional powers. X is t plus 1 to the negative 1/2. So when I do my power rule on that, dx over dt, which would be x prime of t, is going to be negative 1/2 times t plus 1 to the negative 3/2. And I'm going to rewrite that as negative 1 over 2, and then I'm just going to write it as t plus 1 to the 3/2. You could, if you wanted here, use square roots and stuff like that, but it's unnecessary. So let's go ahead and now find dy over dx. So I'm going to circle dy over dt in red. It's going to go here. And then I'm going to circle dy over dx in blue. That's going to go, or see, dx over dt. And that's going to go here. So what I need to do is divide the red one by the blue one. So let's go ahead and do that. Dy over dx is, all right, red is negative 1 over t plus 1 squared. Oops. And then all over the blue. So negative 1 over 2, open parentheses, t plus 1 to the 3/2. So with this, you might be like, I'd rather just leave it like this, but I'm going to try to, like they don't like it when we do this, and this is probably more like a multiple choice type question that we would see on an AP test. So I want to simplify it. You might also see that like it simplifies pretty nicely. So this is, I'm going to copy dot flip or multiply by the reciprocal, whatever you want to think about it. Although I guess before I do that, I'm going to say these negatives cancel and I just get positive. And you could do that later if you want, but I'm going to do it now. So the copy is 1 over parentheses t plus 1 squared, the dot, and then the flip, I'm going to flip the bottom of the fraction. I get a 2, open parentheses, t plus 1 to the 3/2 all over 1. So what I want you to see here is a bunch of stuff cancels. I, in the bottom, have a t plus 1 squared. In the top, I have a t plus 1 to the 3/2. That's 1.5. So and they're the same inside the same pieces being raised to those exponents. I got the same base for both of them. So they're going to cancel out a little bit. This one is going to go completely away, and this one is going to be left with just a half or 0.5. I'm going to write it as a half. So I get a 2 in the top. That's this 2. Over the half power is a square root. So I get square root of t plus 1. So That's dy dx in terms of t. If I was asked for or if this was a multiple choice question, and like the answer would be written in this form, it wouldn't be written in this super messy, crazy form. So you should be able to get to these. All right, next we'll do B. Okay, part B. So I erased some of that stuff. Let's go through what they're asking us. They asked for the equation of the tangent line to C, the curve, at t equals 3. So I am definitely going to need dy over dx. That's going to give us our m. But I do want to remind you that anytime we hear tangent line, we think y minus y1 is m, open parentheses, x minus x1. So let's do the m first, because it's kind of the easiest part or the part that we have right in front of us. So m is equal to dy over dx evaluated at t equals 3, which is going to be 2 over square root 3 plus 1. Well, that gives me 2 over, I get a 4, square root it, I get a 2. Oh, m is just 1. So we'll write a little arrow. This is going to be 1. Next, I need to find x1 and y1. So previously, before we did parametric equations, you would be given one of these really, and it would be obvious what it was. We got t equals 3. You may think, that goes in here. But no, what I need to do is plug t equals 3 into x of t and y of t, and that's going to give me x1 and y1. So I'll do x1 is x of, not 1, undo, is x of the t value, which is 3, which gives me 1 over square root of 3 plus 1, which is going to give me 1/2. And then we'll do, so that's going to give me, this right here is 1/2. Now, let's do y sub 1, because that's the notation we're using, is the same as y of what? What do we plug in? 3. So that gives me 1 over 3 plus 1, which is 1/4. From there, we are just going to plug all of these values in. That's not a very good arrow. This is 1/4. So my final answer is just going to be y minus 1 over 4 is equal to m, which is 1 times x minus 1/2. I'll say that while this is point slope form and oftentimes it's acceptable answer, they might on the AP test not give it to us in this form. So I'm going to go ahead and simplify a little bit. This is the same as y minus 1/4 is when I distribute the 1, I just get x minus 1/2. And then I can add 1/4 to both sides. I get y is equal to x minus 1/2 plus 1 over 4. And you should know that a negative half plus a positive fourth is negative 1/4. So y equals x minus 1/4 might be the answer that they would give on the AP test. If it was one of my tests, I would take either of these two. Totally fine. So part C says find an equation that has just x's and y's. So this is sort of a pre-calculus skill, to be honest. But in general, what you want to do, it's called eliminating the parameter. We want to solve for t in the x equation and plug that in to t for the y equation. So I'll walk through that process. X is equal to 1 over the square root of t plus 1. I can do a variety of things here, but I guess what I'm going to do is square both sides. That gives me x squared is equal to 1 over t plus 1. Because the 1 squares out to a 1, and then the square root in the bottom gets canceled with that piece. From there, I'm going to flip both sides in order to help you see why I can do that. I'll put that over 1. There's some other algebraic ways to do this, but I think this is the easiest way to explain it. So what that gives me is, 1 over x squared is equal to t plus 1 over 1, which I could write in a better way as 1 over x squared is equal to t plus 1. The last step there is going to be to solve for t, and I'm going to switch which sides of the equation these are on. So I get t equals 1 over x squared minus 1. From there, this is going to replace the t that's right there. So I will write y is equal to 1 over t plus 1. The t is going to get replaced with this right here. So I get y equals 1 over boink boink plus 1. That gives me 1 over x squared minus 1. So I'll simplify that briefly. 1 over x squared minus 1 plus 1. What happens real nicely there, the minus 1 and the plus 1 wind up canceling each other. So I get y equals 1 over x squared. And this is something we do a lot. I can copy dot flip, multiply by the reciprocal. That gives me 1 times x squared, squared over 1, which just simplifies to x squared. So y equals x squared is this equation written just in terms of x and y, which is really weird because it's a parabola and it's very simple, and these two are not very simple. So this is a really weird parameterization of y equals x squared. It's just an alternative way to write what these guys are. All right, that's all. Thanks.